Hey there, welcome to my integration by part video. So for those of you guys who don't know what integration by part is or don't remember, integration by part just means splitting up a complicated or unsolvable integral. So all integrals can be put into this formula right here, where you split it into two things that you know. That's going to be u and dv. That way, once you get this, you just follow this formula, and you just need to do a couple derivatives and antiderivatives to get and fill out this equation, right? So if you're still a little lost, I'm going to go through a couple examples. Number 1, the integral of x to the e to the x. So already you know that with standard integration you cannot solve this. You're going to have to do something different. Luckily, integration by part can be used. So when you want to get this into this formula, it's really helpful to set up just a little table here. So you want to get your u value, your du value, your dv value, which is this part, and your v value. So when you set this up, you just want to split the integral in different parts and put them in here. So you know that the standard integral is made of a u and dv. So we're just going to split this up into that. Just from experience, it's a nice rule of thumb to make your u be something that's pretty simple to use, because you're going to have to be multiplying it again when you're doing your second integral. So it's nice to choose a simple u value that it'll have a simple derivative, so it'll all work out pretty smoothly. So lucky for us, we have x to choose. So we're going to make u equal to x. That means the derivative of u, which is equal to x, is just going to be dx. But the other part is going to be our dv, which is going to be e to the x. And so when finding v, we need to do the antiderivative of our dv, which lucky for us is just e to the x again. Then you plug this all into that formula. So you know that it's going to be equal to u times v, so x e to the x, minus the integral of e to the x, which is our v, times our du, so dx. That's a pretty simple integral to do, we all know that. So we know the final answer is going to be equal to x e to the x minus e to the x, and you have to remember your plus c. So that's just a very simple one. We're going to go into a little more in depth and just show you what these all. Next one is even trickier. We're going to do the integral of arctangent of x. Now, I know what you're thinking. That's only one part. That's going to be simple. You don't need to do integration by part. Well, I'd like to see you do the integration of arctangent. Normally, we're only used to doing the derivative of arctangent. We all know that. It's one of the common trig things. So, if we know how to do the derivative of this, how are we going to be able to solve the integral? Well, lucky for you, integration by part is all you need. Because look, this u value, all we need to do is find the u and the du. So if we make our u equal to arctangent, we know our du is equal to 1 over u squared plus 1. That means we need a dv value. So our dv will be equal to dx. So that means our v, through antiderivative, is just going to be x. Alright, so going through, we're going to get x arctangent of x minus the integral of x over x squared plus 1 dx. Now for this, we can solve this just by doing a completely normal u sub. So if we know that u is equal to x squared plus 1, our du is going to be equal to 2x. Now that'll all cancel out, so we'll get x arctangent of x minus 1/2 integral of 1 over u du. Keep going through, x arctangent of x minus ln u over 2. Plug in for u again, and we get our final answer as x arctangent x minus ln x squared plus 1 over 2 plus that all-important plus c. So now we know that we could solve complicated, or like I said, the insolvable integrals by using integration by part, even if there is only one piece that you can use. So that's going to be a helpful trick when you're doing tricky integrals with trig functions. It's really helpful with that. Now, I have my final example here. This one I say is just about as tricky as they're going to get with integration by part. So we have the integral of e to the x sine x. Feeling scared yet? Probably not. Seems pretty simple. Pretty tame things. We all know this. Alright, so u is equal to sine x. Du equal to cosine x. That means our dv is equal to e to the x. V is equal to e to the x. Easy peasy. Now we get our e to the x sine x minus integral of e to the x cosine x. Alright, we just gotta do another one of these. We got to do another integration by part. We're pros at this. We know what we're doing. Let's just put the table over here. U equal to cosine x. Du is equal to negative sine x. dv is equal to e to the x. V equal to e to the x. Easy stuff. So we're just filling it all in again. Plus, minus, again, the integral of, oh no, e to the x sine x. Oh, here's the trick then, huh? We have what we're trying to solve for in our integral. That means we've created a loop. Now how are we going to solve if there's going to be an infinite loop of these integrals going on forever and ever and ever and ever? Luckily, we have an easy trick. See these equal signs right here? That just means it's equal to this. So that's another part of the function. So, if this is equal to this, we could just bring those parts over there and we'll have the thing solved. So we have e to the x sine x dx is equal to e to the x sine x minus e to the x cosine x minus integral of e to the x sine x. Add this to this side, you'll get 2 e to the x sine x dx equal to e to the x sine x minus e to the x cosine x. Divide both sides by 2, and you get your final answer. Plus, let me just erase this side. Plus that all-important c. You can, by the way, do bounds like this. I just feel like it's so simple that it's not really worth explaining or going over. I just wanted to make sure we could get the important tricks that you might run into when you're doing integration by part. So hopefully after this video you'll feel like you know all the tricks and you'll be able to do this on your own. But if not, I will have a link to a worksheet I made, which has a key as well, and it has tons of other rigorous problems on there in case you're worried. Hope this all worked out for you, and hopefully you can check out my other videos too. Alright, bye.